This is Mrs. Robertson, or good afternoon if you're watching this later in the day. We're going to be talking about inequalities today. So make sure you put your name. Today's date, it is January 20th. And what is the definition of an inequality? An inequality is a math sentence that compares quantities. It's a math sentence. That means it's got symbols in it instead of words. A math sentence that compares quantities. Q-U-A-N-T-I-T-I-E-S. Now, here we have, this symbol stands for less than. Let's see, what did your book have in it for the definition? So I keep the first couple just like less than is fewer than. All right. Then on the next one, you have is greater than. That's the greater than symbol. And then they have is more than. And there's another one that you will see, exceeds. So write the exceeds. If it says something exceeds, it's going to be greater than. All right? Then you have is less than or equal to. See how it has that bar there? That means it can equal it. So this is less than and equal to. Or I should say not and, or equal to. That's what your book has. Is at most. And I have one more for you to put underneath there. Another one would be no more than. This is one they use a lot in 7th grade. And I think it's used in the worksheet down below, so I want you to know how to use these words. Make sure you added no more than. On the next one, greater than or equal to. Another word, at least. And another word that you will see, no less than. All right, now we're going to go on and interpret these math sentences. All numbers less than 7. Let's use the variable x for this. All numbers less than 7. I know I have a 7, my variable. Is it equal to 7? No, it is less than. Less than is right here. That's the symbol you're going to use. All right, any questions on that? Let's go to the next one. You want to spend at most 40. Put down an X, put down a 40. Now, can you spend $40? Yes. So you're going to put the equal bar down. Are you going to be able to spend more than 40 or less than 40? At most looks like what? Less than. So it's, yes, like that. And see here the words at most are right there if you have the chart. But let's say on a test you don't have the chart. I always ask myself, can it equal it? Then you put the equals thing. And then I say to myself, can it be bigger or is it going to be smaller? And that's what you talk to yourself when you do these. They're not that hard then. More than 50,000 fans were in attendance. Is it equal to 50,000? No, it's more than, so it's going to be bigger than 50,000. Got it? A number times 3 is greater than 42. So the way you write a number times 3 is 3x. That's a number times 3. Do you see how to write that now? Is greater than, you know what that looks like, 42. Any questions on how I wrote that? Okay. Wesley scored at least 3 runs in last night's game. X represents Wesley, how many runs he scored. Now, did he score 3 runs? Wesley scored at least 3 runs. So he scored 3, yeah. Could he score more than 3 or less than 3? More. So it gets the big end. And remember, the big end, that means it's more than. X has the big end, it's more than. If your variable has the little point, it means it's smaller than. Okay? Tonight's homework has no less than 60 problems on it. Can it equal 60 problems? So yes. Are you going to have more than 60 or less than 60? More, because it says no less. No less is the same thing as more. So it could have 60 problems or more. No less is the same thing as more. Okay? And if you look up here, no less is that symbol. Is that what we used here? Yes. 3 times a number, so that's going to be 3x, increased by 6. That means plus 6. Do you see how I wrote that? 3 times a number, that's 3x, increased is plus 6, is at least 24. Can it equal 24? Yes, at least. At least looks like this. So 24 is the smallest it can be. It can be 24 or bigger. All right? Now, with this chart, it's really easy. You go, oh, I got the words at least. At least looks like that. But on a test, you won't be able to use this chart. So you just want to be able to start asking yourself these questions. 5 more than 4 times a number. So you're going to have 5 plus 4 times a number. Now, a better way of writing that is 4n plus 5. Is greater than, well, that's easy, 17. Any questions on that? We hadn't had one, that with just the greater than. That was simple. So 4n plus 5 is greater than 17. Any questions on how to do these? Kids, we are going to practice writing these every day for 3 to 4 days, all right? Because right now, with the chart, you're not bad at it. I'm really impressed. I think you're doing pretty good. You're talking to yourself. Is it equal to it? We just need to practice and build confidence. Now let's go to our next page. Define inequality. Well, we already defined it on the other page. All you are doing is an inequality. It's a math sentence where you compare quantities. Now, let's do this section first, and then we're going to go do this part here. Match the inequality with its verbal phrase. My technique is I read the numbers and then see which one of these matches it. All numbers less than or equal to 7. X is less than or equal to 7. Which one says that? 3, right? So what I do is I write it down and then I find my match. All numbers greater than 7. X is greater than 7. Which one says that? Which one is the same thing as this? 2. All numbers greater than or equal to 7. Greater than or equal to 7. Which one is that? 4. All numbers less than 7. That is 1. Any questions? Do you see, are those hard? Is it easy to make a mistake if you don't read carefully? It can be, but you kids are all pretty good. Thumbs up on this section. Are you all pretty good at that? Good. Now let's go to the next one where we have symbols, and we're going to talk about how to graph them and the meaning. Okay, are we ready? That means less than. When you do your graphing circle, it'll be an open circle. This will make more sense to you in a moment. Greater than, open circle. Less than or equal to. When it has that line underneath it, it's a filled in circle. Okay? Greater than or equal to, it has that sign, so you have to fill it in so you know to include it. Does everyone have that? And not equal to, just draw a circle with the line on it, okay? Does everyone have that down in your notes? Am I going too fast? All right. It says we can graph inequalities. Now, inequalities, kids, just means less than, greater than, less than equal to, greater than equal to. That's all that word inequality means. I have seen kids, when they're doing a test, they say, I don't know what an inequality is. It just means to write an equation, but instead of an equal sign, you use one of those inequality signs. Okay? Now read the information below and fill in the table above appropriately. Well, we've already filled the table in, but if you forgot, a closed dot is used when the endpoint is included in the solution. That means you're going to use it for this one or that one. It's got the equal bar. An open circle is used when the endpoint is not included. That means that one or that one, you have an open circle. All right? Now, we have to interpret this graph. Write the inequality for each graph. Well, I'm going to use the variable x, and it's on a 0. Now, it's going to the left. Little numbers live to the left of the point, so x is going to get the point. Is x less than 0, or is x less than and equal to 0? It's a closed circle, so which sign do I use? X is less than and equal to. When it's a closed circle, it has to have this bar underneath it, okay? Now let's go to this one. X, the circle's on the 3. It's going to the right. That's where the big numbers live. Big numbers always go to the right. The little numbers go to the left. So, yeah. Okay. All right. You guys just check my Google Classroom for the rest of the assignment, okay? Because we'll be doing some things in the book. So, is x going to be what to 3? Greater than. It's not equal to because it's an open circle. X is greater than 3. Any questions on that? Okay, now we're going to graph these. There are no numbers. So kids, all you have to do is write down 3 numbers on each graph. 0's in the middle. It's -1 and 1. Okay? Now, am I going to put an open or a closed circle on 0? It's got that line, so put a closed circle on your 0. Alex, put a closed circle. Now, W has the big end. Where do the big numbers live, right or left? Right, so it goes to the right. Got it? -4, -5, -3. Just put down 3 numbers. Now, on my -4, is it going to be an open or a closed circle? Closed, because it's got that bar. Now, it says B is less than or equal to -4. Where do the less than numbers live? Left or right? Left. Good. All right, this one, I put my 5 in the middle. 4, 5, 6. Now, J is greater than 5. Am I going to put an open circle on my 5 or a closed circle? open because it doesn't have the line. Now, J is greater. Where do the greater numbers live, or the big numbers? To the right. See how easy this is? You just have to ask yourself the right questions. You're doing a nice job, kids. Let's go on to this problem here. -2, -3, -1. Am I going to put an open or a closed circle on my -2? Very good. Now it says t is less than or equal to -2. Where do the less than numbers live? Left. Okay, -5, -6, -4. Am I going to put an open or a closed circle on my -5? Right. J has the big N. J is greater than -5. Where do the greater numbers live? To the right. 0, -1, 1. Am I going to put an open or a closed circle on 0? Open. Is it going to go to the left or to the right? The left. Y is less than. Okay, save this paper. Are you pretty good at this? Good. Now let's go to our math book, and we're going to talk a little bit about our lesson 5. And it is located on page 617. Or do I want to do the inquiry lab? Let's do the inquiry lab instead. Yeah. We're going to go to page 615, kids, the inquiry lab. 615. On this page here, it says, how can bar diagrams help you compare quantities? In saltwater water fishing, any flounder that is caught may be kept if it's greater than or equal to 12 inches long. So if it's smaller, you have to throw it back in the lake or in the ocean, wherever you're fishing for a flounder. Any flounder shorter than that must be released back into the water. Pat caught a flounder that is 14 inches long. He wants to know if he can keep the fish. Well, here we have our hands-on activity. And it says, an inequality is a mathematical sentence that compares quantities. Well, we talked about that yesterday, or earlier today, and that's what we came up with, the same definition. An inequality is a mathematical sentence that compares quantities. An inequality like x is less than 7 or x is greater than 5 can be written to express how a variable compares to a number. Well, let's look at step 1. Label the minimum length of flounders that may be kept. Okay, what's the smallest flounder that you can keep? 12 inches. So let's write 12 inches on this. That's the minimum that the fish can be. It has to be 12 inches. Label the length of the flounder Pat caught on the top diagram. Okay? And then we have the 12 inches on the bottom. How long was the flounder that he caught? Yes, Alex? 14 inches. The bar representing Pat's fish is blank than the bar representing the minimum length that can be kept. So his bar is longer. Maybe you would say greater, but it's the book here used longer. So, Pat blank keep the fish. Can Pat keep this fish, or does he have to throw this fish away? Or throw it back in the water? He gets to keep this fish. So he can keep the fish. Any questions on this page? Pretty easy so far, right? Okay, let's go to page 616. Work with a partner. Draw bar diagrams to solve each problem. Now, I am going to let you work with partners. Let me pause, and then we'll go and look at what our answers look like, and if you need to make an adjustment. But what you're going to do is draw two diagrams similar to here. You'll draw something, and then you'll draw another one. One is probably going to be longer than the other one, okay? And label them. So you may work with a partner. You can work on 1 through 6 together. I will give you about 10 minutes, 10, 15 minutes, and then we'll talk about our answers. All right? You may work with your partner. All right. So for number 1, most of you, it's like, why do we even have to draw the picture? Because it says so. But the answer is no. So kids, no. It says, can she take the luggage on her flight? No, it's 3 pounds too heavy. Now, if she opens up her suitcase, finds something that's 3 pounds and puts it on her, maybe her coat, gloves, something else, then she can put it back on. But she's going to have to take 3 pounds out of that suitcase. I'm going to put this on pause here. Okay. Brian needs at least 20 minutes between the end of his soccer practice and the start of his... Gentlemen, we're going over these. His practice ends at 4:30 and his appointment's at 5. Does he have enough time? Yes. He has 30 minutes. So time needed, 20. Time available, 30. That's what your graph should look like in number 2. Time needed, 20. Time available, 30. Shh. It's good to practice using the types of words they want. Because I've noticed sometimes you know what to do, but you don't know what to write down. Now let's look at number 3. Which inequality is used when the situation involves a minimum? Okay, which inequality? Greater than. By using the term minimum, the situation is asking for the least value possible. So all other values that make the inequality true would be greater than or equal to the minimum. Okay, so you could have greater than or greater than and equal to would be the minimum. Everyone have that written down? Let's get that written down. In number 4, which inequality is used when the situation involves a maximum? Less than. When they have the word maximum, you're going to use the less than sign or less than and equal to the maximum. It says by using the term maximum, the situation is asking for the greatest number possible. So all other values would be less than or equal to the maximum. Okay? Now, I would like for you to go to page 621, and I want you to do 1, 2, 3, and 4 on page 621. Kids, listen. It says, determine which number is a solution to the inequality. One or more of these are the correct answer. In number 1, these are your choices. Is 5, 6, or 7 true for this? Now, is 1 plus 5 less than 7? 1 plus 5. Is that less than 7? Is 6 less than 7? Yes, it is. So 5 is an answer. Is 6 an answer? Is 1 plus 6 less than 7? Is 7 less than 7? No. And then you know that 7 won't be true because it's going to be greater than 7, right? So, let's just put a big X for that. So the answer to that one is 5. So go through and find the right answer. And then you tell me if this is true or false. There are 3 problems. Let's get them finished. They don't take very long to do.